Attempt to explain what we're going to do here. This is a new process 246 GM transfer case. Of course, this is an electronic shift, and this is also a automatic shift, so you can put it like in four-wheel drive standby, and if the computer senses that the front axle is spinning faster or slower than the rear axle, it will automatically engage the four-wheel drive. Well, what we're going to do is attempt to make this a double reduction transfer case. Okay, so I got a lot of parts out here, and I'm just using these for illustration to show what we're going to try and do here. So first off, what we're going to do is take this part of the transfer case, and this has the planetary gears right in the bottom of it. And so we're going to cut this off right across here. Just wipe that off. Get back here where we can kind of see what I'm doing. We'll cut that off and get rid of all that stuff. Then we'll cut it off right across here, just above the planetary gears. Okay. Then we're going to machine this all off to where it's smooth on the outside, so that we can fit it down in here. So we have two sets of planetaries. One for the single reduction and a second one for a double reduction. Okay. Now this here is the clutch out of this transmission. You can see it's all burned up, so it's no good. But for size comparison, you can see this is what we've already turned down on the outside. We machined this all off, and this is what we end up with, which has got a set of planetaries like that. And once we remove this clutch, and this is just a clutch drum fit on the shaft, so you can see approximately where everything fits. But once we take this off, we can replace it with this to get our double reduction. And you can see pretty dang close to the right side. Of course, this has got a big shift fork on here that engages this clutch. So that's pretty big, about that wide. Here we are. Yeah, this is the engaging thing. You can see how that's pretty heavy duty, you know, it sticks way out there. So when we measure this up, it does measure like it's going to fit in there. It'll be how to get the shifter to work. So that's kind of where we're headed there. A couple of things that we are going to have to work with, because the output drive on this is not hooked directly to this shaft. Of course, it goes through the planetaries to get your direct drive or your reduction drive. So in order to make it work on a second one, we're going to have to cut this shaft and fit in pilot bearing like this, and the bearing for the outside that supports it across here, so that everything will stay lined up. So this is the piece I'm going to use right there. See, I've already got it cut off, and we'll machine that down. Fit right in here. So we still got to machine this. I'm going to machine this down so that it fits right inside there, and then weld that in place. We're going to weld it on the outside, and we're also going to weld it on the inside. We'll have to clean it up because there's a bearing in there. It's have it out to work on it, but it's got to go back in to support the end of this pilot. Of course, this pilot will go into the first one, but we'll have a second pilot that goes into this one. So, anyway, you can see some of the things we're going to have to address and figure out how to make this all work. Now, on the inside of the case, the one that we're going to use, we're going to have to machine this out so that this will fit down in it. Okay, this is the case we're going to use. So we got our first set of planetaries in there. This is the shifter and the shift arm. Now with this part of it, we can use all the original linkage to go from direct drive to low range right there. So when we install the second set, so it's this shaft, of course, will go right down in there, and it'll be welded to the inner ring on this set of planetaries to deliver power from this set to the next set. Actually, vice versa, because this is the input side here. This is the transmission side. So anyway, I don't know if I can do this one-handed. Anyway, that'll fit right in there like that. And I think we'll have to modify this shift arm thing here, because it's got all these springs in, which we don't really need now. And we'll take a second shift arm, put it right on that shaft, so that we can shift this one from direct to low range, just like that. So, anyway, that's about as far as I've gotten so far. We're going to work on this linkage now and getting our clearances. I still have to do some machine work on this piece, and there's also a bearing down in the bottom of this piece that supports the shaft, and that's going to have to be machined because I've got to drop it down some to keep our clearances low here as you can. You can see this will be the bottom of the gear that holds the chain, the sprocket that holds the chain. Of course, it'll come across here, and the second sprocket will sit just above the shift collar. So you can see we don't have a lot of room there, so we're going to have to see what kind of interference we got and and what we're going to have to do to make that happen. We may have to modify this some. We can shorten it a little bit right there. I can drop the whole thing down a little bit, but not a lot. So anyway, that's kind of where we're headed here. Ambitious little project that if it works, it ought to be pretty cool. So let's see what happens from this point. Well, I videoed this once, but I lost it. I don't know what happened, but I wanted to show how we put this part together. What we had, this is the input from the transmission, and then it goes up and transfers power through your planetaries, and then on into the transfer case. So what we did was cut this off about right here. A bearing fits right there. So we cut this off right here, and then we took our spline piece, we machined this to where we've had a 3,000 press fit, which is really tight. So anyway, we pressed that down in there, dialed it in, and then welded it. So we also welded it on the inside, which I can't show you the weld because I put the bearing in there. This pilot bearing for this part, for the second set of planetaries. So anyway, that piece is ready to go. And then of course this piece right here goes into this set, like so. Then our shift collar for the second set of planetaries go on here like so. So anyway, this part, the planetaries, everything, that's all figured out. What I got to do now is figure out how to get this to shift, but I'm running out of room. So I just don't physically have enough room for this and our shift fork. So anyway, this shift fork is for the bottom set, which is the one that we haven't modified, but I just don't physically have enough room for the second set to go in there. So what we're going to do is shorten this whole setup. How this works is it acts kind of like a synchronizer, and so when you shift it, if your shift collar, if the gears aren't meshed, you can shift it, and then if the teeth aren't lined up, it will put pressure on these springs so that when it does line up, it just pops it into gear. So in both directions. So we want to maintain that. It'd be really, really nice for shifting it. But we're going to have to modify this part to make that happen. So what we're going to do is shorten this whole thing by an inch. This is the parts that we got right there. Now you can see I've marked this somewhere. Thought I did. Anyway, we're going to cut a 1/2 inch out of this right there, because this one here only affects one direction. So I'm going to take a 1/2 inch out. Well, this one here will affect both directions. So we're going to take a 1/2 inch here and a 1/2 inch down here. And that'll keep, this is like a guide tang on here to keep everything from twisting. So and this is our follower for a cam. This is what actually pushes when you move your shift cam. It moves this up and down. So we need to maintain this part in relationship to the shift fork here. So anyway, once we got that, then we'll take a 1/2 inch off each end of this, and we'll cut a 1/2 inch off these springs. Now you notice the springs are not symmetrical on each end. You notice how much wider the gap is here than it is here. So what we're going to do is use this end, because when you shift this, if you collapse it too far, then you close this up and the springs are mashed together. You can't go anymore. So we've got to make sure that it will move at least however much that our shift collar needs to go. Well, in this case, on the bottom, that distance is 3/4 of an inch. When I redo the top part, that will be a 1/2 inch, because we're going to shorten this, because we're going to eliminate the neutral part of the second of the set of planetaries. So anyway, that's where we're headed. We'll see how that works out now. Once I get this all cut up and welded back together, we'll put it in and see what our clearances are. And I'm still not sure we're going to have enough room. I think we may still have to shorten this one a little bit, which we may be able to do just by taking some of the top of this part here off from this one. So, but we'll be like within 1/4 of an inch making this work. So I think somehow we can make that happen. Anyway, here we go. We'll try that out. Got our parts all cut up and welded back together. What we're going to do now is put this, we're going to have to clean up a little bit, but I'm going to put this together, and these springs are going to be a bugger to get in there. We'll figure out a way to do it. This is all cut down. So I'll clean them up a little bit and put it together and try it in our transfer case. We have it. This is our new shortened version of our shift work. So now we got to do is put it all together and see if it'll actually shift. But you can see here now we got plenty of room on top and bottom to fit in the case, and plenty of room to shift it. So we'll put her together now and see if it actually works. attempt to reassemble all this stuff now that we've made all our modifications. As I do, I'm going to point out what I did different and why we had to do that. So, guess we can start off with this right here. Of course, this is the planetary set that we took out of the other transfer case. And originally, this bearing, which has a snap ring on it, I don't know if you can see that, but originally it was mounted from this side and was held in place by the seal retainer. It was bolted on there, and that's what held the bearing in. Well, because we need to get more room to physically fit this in there, we got rid of the seal retainer, which we didn't need. We don't need a seal here. And then to keep the bearing in place, we put it in from this side. Now you can see we machined this down to get our clearances right, so that when our shaft goes down in there, that bearing sits right here. So when it goes down in there, it locates these gears for this inner ring. So, and that also, because that shaft sits right on top of this bearing, that'll keep it in place. It can't come up or it can't go down. So, that's one. And another one that we did was this right here, this part of the planetary, which has the chip collar that goes up and down in it. Well, when it's in direct drive or high gear, it hooks down into this to transfer the power up to this spline here, and then the rest of the shaft. Okay, well, normally there would be this position, which is high. It would come out where there's nothing for neutral, and then it would come on out and connect into this set for low range. So what we did was cut right around here on another set of planetaries so we could get these gears. Then we took it off and mounted it right down in there. Okay, you can see where we put it. Right there. So essentially what we did was eliminated the neutral, but we also shortened the stroke that we need from this. So now it only has to move about a ½ inch to go from high gear right into low gear. So that helped a lot with our clearance problems. We don't have to move this as far. So, and I already showed how we welded this up. This is our cam plate, bottom half down here, which rotates to move the bottom shift fork up and down. It fits. Actually, this is upside down. You got to turn it over like this. But anyway, that follows right there. Whoops. So that it'll shift in and out of gear. Okay. So the top one, we just set it. Took another one of these plates and cut it off and put it up here so we would have the slot for the second shift fork. up here. Now there's two ways we could have done this, depending on how we set this up. We could have shifted this one first to go from high gear, high range, to neutral, to low range. Okay, with this one. And then we could have cammed it to where it would then move this one from high range to low range to get our second reduction. Well, I decided, because the way this slides up on this shaft, if I move it first, then I get some interference problems right here. Again, it's limited clearance to get this all in. We already had to shorten this, and we cut off about 3/8 of an inch off the top of this tube to get it to where it worked. So what we decided was to shift this one first, let it shift first, and then your next shift would be this one to bring it into neutral and low. So anyway, that's the theory behind setting this the way we did. So of course, this is our drive gear for the chain, and the shifter for the second set of planetaries fits right on there. Well, normally this would be kept in place with a snap ring. Similar to this, to where you can see right here, there's a place for a snap ring to hold this in. And I would have liked to have done that, but there isn't physically enough room. We had to machine this back on this piece far enough to allow room to shift it like that. So you see, we welded this sprocket right onto the shaft. Isn't that pretty? Yeah. But anyway, we welded that right on there. Plus welded this side also, and then machined it back to make sure that it had enough room for the shifter to put it in and out of gear. Okay. Again, because we just got limited space in there and trying to fit all this stuff in where it's not designed to fit. So anyway, I'm going to start assembling this. Some of it I'll show you as I go, but some of it I can't do one-handed, so I'll do the best I can. And we got to do is get this mounted in. You see that hole down there, wherever it went, right there. That's where this fits, right there. So anyway, I don't know if you can see the little gap in there. Well, inside that, there's about 1,000 little tiny bearings. And I've got to get those little bearings back in there before we put this back in. They run right there. So that's going to take me a minute. Well, that didn't go too bad. It took me about 10 minutes to get all them in there. Only dropped about 6 or 8 of them. Had to retrieve them, but that's quite a trick. Okay, now we put our cam plate together, and it's got a snap ring on the outside to hold it. Here, our cam plate is installed. Snap rings on the back. Next thing we'll do is set our detent. Goes right down there. We'll put it in place. Hold everything lined up. And then we'll go ahead and put our shift collar and our bottom shift fork in place. Shift fork is installed, and you can see it goes from direct to neutral to low range. Okay, and remember, this is all stock. There was no modifications made to any of that. Cam plate the same. The spring setup's all the same. Everything there is all stock. The planetary gear, everything, and this part is just as it was originally. We got our detent in here, and I just put just a little bit of tension on it, just enough to hold it in place, so that when we move this, we can tell when it go there and stay there. But if you tighten it up too tight, it makes it hard to ship. So, and next we'll put on our planetaries. I'll show you how we locate it and hold that in place. This planetary, notice when we machined out the case, we left a lip right there. We'll have to make sure that this is located properly up and down, so we don't get interference from the shift fork or onto the bearing, things like that. So it's pretty critical how deep we could put this down in the case. So when we set it in there, I think I can do this one-handed. I'll try it anyway. It's a really, really nice fit down in there, so it won't move. But what we've done is drilled and tapped some locating holes. There's 3 of them, one here, one over here, and one right here, like so. And these are just, oh come on, no cooperation here would be nice. Anyway, these are 1/4-20. So what we have is we just put a set screw in it, so that we know that when this is down tight, and we measured from the top of the cage down to here to make in 3 places, so we know that it's seated down in there tight. Okay, once we locate those, then this is the hinge pins from the clutch pack that put it into 4-wheel drive automatically. Well, we just cut the end of it off and machine. I'll take this out and show you. We machined a slot right there on each side. And once we get this down, make sure that it's down in the groove tight, then we can tighten these up against this to make sure that it cannot rotate in the case. So I'll go ahead and put that together. Okay, I wanted to point out here a couple of things. That's where the oil pump rides, right here. and it picks up oil and forces it down through that hole. You can see to the center of this shaft. It comes back out to lubricate this slide collar, and then if this were the bottom half of the bottom planetary, it would pump oil down into it to lubricate the pilot bearing and the planetary. Okay, well, when we had to build this piece, we still need to lubricate this bearing and this set of planetaries. So, but if you can see, we had to drill a hole in that pilot bearing right there. That's to allow the oil down through this, through that hole, down through that cap on the bearing, and on down the shaft so that we can get oil to the rest of this. If we didn't do that, it would burn this set of planetaries up pretty quick. They need lots of oil, lots of circulation in there, keep them cool and lubricated. Going to install the second set of planetaries. We got it assembled here. So drop this down in, and there we go. So now we can put in our second shift collar and our shift fork. So, and I know I can't do that one-handed, so here we go. The shift fork all installed. We're lined up in our cam plate and our shift collar. Because I don't have, there we go. Because I don't have this supported, it's a little bit loose right there. Once I put that cover on, everything will be solid and shift just like it should, hopefully. And of course now, we'll go ahead and install the rest of it, the sprockets for here, and the chain. I may run into an issue with this pickup tube. The way it sets in there, whoops, get you back on track here. The way this sets in here, I think I'm going to have some interference problems right here. So I may have to adjust this tube, and then when we shift it, get around here where you can see. This cam plate comes around. I think it's going to hit the tube right there. So I'll play with that a little bit, and then we'll see where we're at. Well, we got lucky here. This is the original tube that came out of this transfer case, but so we looked at the one out of our donor transfer case, and the bend is a little different. It stretches out there to where we don't have any interference. How lucky is that? There we go. That worked really nice. I did bend it just a little bit right here to raise it up just a hair, but we have no interference now, so that worked out really good. Well, I went ahead and put the chain on, Put our snap ring on here to hold this sprocket down on. And we put our there's a spring down on here that this reluctor wheel holds down in place on the inside part of the pump. You make sure you put that in. And then we set the bearing on and put our snap ring on it. So this part is basically finished. So at this point, all we have to do is put the back half of the case on. We'll come back later and put new seals on the input and the output shaft, which they're taken out of the case. I don't have them right now, so when I get those, we can just install them. So, including that one. That one's easy to change. That's a good seal, I think, but because I changed that seal just before we pulled this out of the vehicle. So this is out of Klondike, actually. So anyway, I'll go ahead and put that together now. We'll seal it up and then we'll test everything, make sure it works. I mean, I've tested it like it is, but this really needs to be held over in place by the top half of this case, because any kind of movement right there, and do get just a little bit, makes it hard to shift. So I want to put that all together, make sure everything works good. Have it all put together here. This is not sealed yet, and I've only got a couple of bolts in it so that I can test it, but everything works good. It shifts, goes front. This is our shift pattern. We got direct, and it goes down into L1, which is low 1 with 272 ratio, and then it goes into neutral, and then low 2, which is a 740 ratio. It's actually 398, but that's close enough for me, and it all works. So yeah, I'm really happy about how this turned out. So I guess our next step is to get it in a vehicle and test that part. But yeah, I'm really happy about that. I won't be putting it in a vehicle for a while. I'll try it out in Klondike first, because it's a direct replacement for what it's got in it. So anyway, there we go. That's a done deal.